Your 4-year-old can unlock a tablet faster than you can tie your shoes. But here's the question that keeps a lot of parents up at night. Can they actually learn to think like a programmer without racking up even more screen time? Turns out, yes, and the method is surprisingly tactile. My name is Dr. Priya Mehta. I'm a child developmental psychologist, and I've spent years studying how young kids learn computational thinking through hands-on, screen-free methods. You're listening to the STEM Lab podcast. Quick heads up before we get rolling. Everything you're about to hear, the research, the data, the script, all of that comes from real human experts and has been thoroughly verified. But the voice you're hearing right now, that's AI generated. Just wanted to be upfront about that from the start. If you've been listening for a while, thank you, really. It means a lot that you keep coming back. And if you're new here, welcome aboard. New episodes drop every Monday, Wednesday, and Friday, so you've got a lot to dig into. Now, let's get into what we're covering today. So let's start with the big question. What exactly is screen-free coding? Screen-free coding, sometimes called unplugged programming or tangible coding, teaches the core concepts of computer science using physical objects instead of screens. We're talking about algorithms, sequences, loops, debugging, conditionals, all the building blocks of real programming. But instead of tapping a tablet, your child is arranging wooden command blocks, moving a programmable robot across a mat, or playing a board game where they plan out instruction sequences to reach a goal. The magic here is what I call tactile abstraction. Children can physically hold a move forward tile. They can flip it over, reorder it in a sequence, and watch immediate consequences unfold when a robot follows their instructions. This concrete interaction helps young minds grasp abstract concepts that would feel completely intangible on a screen. Screen-free coding tools range from simple directional puzzles for 3-year-olds all the way up to sophisticated coding board games that introduce functions and variables by age 7. Unlike apps that hide the logic behind animations, these tools make cause and effect visible and reversible. Your child isn't just tapping buttons, they're building mental models of how instructions create outcomes. That's the same fundamental skill professional developers use when they're writing Python or debugging embedded systems. This approach aligns beautifully with Montessori and Waldorf principles that prioritize sensory engagement during early cognitive development, while simultaneously introducing children to logic structures used in actual programming. Now let's talk about how screen-free coding actually works. The mechanics are deceptively simple. Your child creates a sequence of physical instructions, tests the outcome, identifies errors, and refines their approach. But beneath that simplicity, multiple cognitive processes are activating simultaneously. Most screen-free coding tools follow a 4-step cycle that mirrors professional software development. First, plan. Your child examines a challenge. Maybe it's getting the robot from point A to point B, navigating a maze, or collecting specific objects in order. Second, code. They select and arrange physical tokens, command cards, wooden tiles, color-coded blocks. These represent actions like forward, turn left, repeat 3 times. Third, execute. They activate the sequence, either by pressing a button on a robot or manually stepping through each instruction. Fourth, debug. When the outcome doesn't match expectations, they identify which instruction failed and reorganize the sequence. This loop is identical to the compile, test, debug cycle professional programmers use, but it's happening in 3 dimensions with immediate, visible feedback. A 4-year-old placing forward, turn right tiles and watching a robot execute those commands is experiencing the same logical process a software engineer uses when writing code, just without syntax errors. Let's talk about what's happening cognitively when kids manipulate these physical objects. Physical objects engage different neural pathways than touchscreens.
When your child picks up a loop tile, rotates it, and slots it into position, they're activating fine motor control, spatial reasoning, and executive functions simultaneously. Research in developmental psychology shows that children under 7 develop abstract concepts more effectively when they can manipulate physical representations first. The tangible repeat 3 times block becomes a mental schema, though recognized later when they encounter 4i in range 3 in Python. I've watched my own daughter, at age 5, grasp the concept of nested loops using a hands-on coding robot by physically placing a loop card inside another loop sequence, something that would have been cognitively overwhelming as lines of code on a screen. Quality screen-free coding tools scale complexity through expandable instruction sets, not software updates. A beginner might work with 4 commands: forward, backward, left, right. As competency grows, you introduce loops, conditionals, and functions using additional physical pieces. The child's hands-on understanding deepens without requiring internet connectivity, subscription renewals, or age gating through software. Check the show notes for a link to the current price. This physical progression builds transferable mental models. When your 8-year-old eventually opens Scratch or begins writing Arduino sketches, they're not learning logic for the first time. They're translating concepts they already understand into new notation. So why does screen-free coding actually matter? Beyond the obvious benefit of reducing screen time, what is this approach really preparing your child for? The answer goes deeper than future job skills. First, we need to talk about protecting developmental windows. The American Academy of Pediatrics recommends limiting screen time for children under 5 because early childhood is a critical period for attention regulation, impulse control, and social development. Screen-free coding gives you a way to introduce computational thinking, which is a genuine 21st century literacy, without sacrificing those developmental priorities. Your preschooler builds problem-solving resilience through trial and error with physical robots, developing frustration tolerance and spatial reasoning simultaneously. Then there's the matter of building true computational thinking.
Computational thinking isn't about knowing which button to press. It's about decomposing problems, recognizing patterns, abstracting principles, and designing algorithms. These metacognitive skills apply far beyond programming. A child who learns to break a complex maze into smaller subproblems using physical coding cards develops the same analytical approach they'll use in algebra, scientific experimentation, and engineering design. For parents planning a progressive STEM learning path, screen-free coding serves as the foundational layer that makes later transitions to text-based languages feel intuitive rather than overwhelming. And here's something that surprises a lot of parents. Screen-free coding is actually preparing kids for industry-standard tools. The logical structures children master through physical coding, sequence, iteration, conditionals, functions, are universal across programming languages. A 6-year-old who understands that repeat until you reach the wall is a conditional loop already grasps the concept behind while distance is greater than 0 in Arduino or Python. You're not teaching toy logic, you're teaching the fundamental control structures software engineers use daily, just in a developmentally appropriate format. Now, let's break down the types and variations of screen-free coding tools you'll encounter. Screen-free coding isn't one-size-fits-all. Different tools target different age ranges, learning environments, and skill milestones. Here's how the landscape breaks down. First up, programmable robots without displays. These are battery-powered devices that execute physical command sequences. Some have directional buttons right on the robot itself. Others use coding cards that you place on a scanner. They provide immediate kinesthetic feedback. Your child sees the robot move exactly as instructed, making cause and effect relationships concrete. They're ideal for ages 4 to 8 and require no apps, though some offer optional screen-based extensions you can ignore.
Most run on 3 or 4 AAA batteries, giving you 6 to 8 hours of use. They operate offline, many include washable mats. Look for models with expandable command sets like obstacle cards or function tiles, so the tool grows with your child. Next, board games and card-based systems. These translate coding concepts into cooperative or competitive gameplay. Players use instruction cards to navigate characters, solve puzzles, or outmaneuver opponents. They're excellent for family learning and require zero technical setup, no batteries, no charging, no firmware updates. Skill outcomes include planning multi-step sequences, predicting outcomes, and strategic thinking. They work well for ages 5 to 10 and integrate seamlessly into existing family game nights. Then there are construction-based coding kits.
These combine physical building, think Lego style or wooden, with programming logic. Children construct a marble run or chain reaction machine, then code the sequence of events using placement and physics. They emphasize spatial reasoning and engineering thinking alongside logic, making them ideal for kinesthetic learners ages 6 to 12. Finally, paper-based, unplugged activities. This is the most minimal approach. Printable mazes, grid-based challenges, algorithm design worksheets. Zero cost, infinitely duplicable, perfect for classroom environments or travel. They lack immediate feedback but excel at teaching planning and mental simulation before execution, a critical skill in professional programming where you mentally trace code before running it. Let me address some of the most common questions parents ask me about screen-free coding. What age should I start screen-free coding with my child? You can introduce basic sequencing concepts as early as age 3 using simple directional puzzles and single-step command tools. Most structured screen-free coding tools target ages 4 to 8, when children can plan multi-step sequences and understand cause and effect relationships. The key is matching tool complexity to your child's ability to hold a plan in working memory. Start with 3 to 4 step sequences and scale up as they demonstrate mastery. Do screen-free coding toys require subscriptions or ongoing purchases? The vast majority require no subscriptions. They're one-time purchases with no cloud dependencies. Some offer optional expansion packs, additional command cards, themed bats, advanced challenge booklets. These extend learning pathways, but the base kit functions completely offline and indefinitely. Always verify that a tool doesn't require app pairing for core functionality if true screen-free operation is your priority. How do I know when my child is ready to transition from screen-free coding to actual programming? Watch for 3 readiness markers. Your child confidently plans 8 to 10 step sequences. They troubleshoot logic errors independently rather than asking for help, and they express curiosity about what else the robot could do beyond its physical capabilities. These signal they've internalized computational thinking and will benefit from the expanded possibility space of screen-based tools like Scratch. Typically, this happens between ages 7 and 9, though individual timelines vary. Can screen-free coding actually prepare children for real programming languages? Yes, the logical structures are identical. Professional programmers use loops, conditionals, functions, and debugging daily, regardless of whether they're writing Python, JavaScript, or C++. Screen-free tools teach those concepts in a format young children can grasp, creating mental schemas they'll apply when they encounter text-based syntax later. The transition feels natural because they're not learning new logic. They're learning new notation for concepts they already understand. What's the difference between screen-free coding and regular STEM toys? Screen-free coding tools specifically teach computational thinking and algorithmic logic, the mental processes used in programming. Regular STEM toys might focus on physics principles, engineering challenges, or scientific observation without necessarily teaching the step-by-step conditional reasoning that defines coding. A marble run is STEM. A marble run where you pre-program the path using command cards is screen-free coding.
The distinction matters because computational thinking has become a foundational literacy, applicable far beyond computer science. So, let's pull this all together. What is screen-free coding? It's your family's opportunity to introduce computational thinking during the years when hands-on learning creates the strongest neural pathways, without adding screen time during developmentally sensitive periods. By teaching sequencing, loops, conditionals, and debugging through physical objects like robots, board games, and construction kits, you're building the same logical foundation professional developers use, just in an age-appropriate format your preschooler can touch, rearrange, and test. The tools require no subscriptions, they work offline, and they scale from simple 3-step sequences for 4-year-olds to complex multi-conditional challenges for elementary students. You're not delaying real programming, you're making the eventual transition to Scratch, Python, or Arduino feel intuitive because the underlying concepts are already familiar. This isn't about avoiding technology forever. It's about giving your child's developing brain the sensory-rich, error-tolerant, physically grounded introduction to logic it needs before abstraction makes sense. The command blocks they arrange today become the mental models they'll use to write code tomorrow. That wraps up this episode of the STEM Lab podcast. Thanks for spending this time with me. We'll be back with a new episode every Monday, Wednesday, and Friday. If you found this helpful, I'd really appreciate it if you'd leave a 5-star rating and write a quick review. I know it sounds like a small thing, but it genuinely helps other parents and educators discover the show. And if you haven't already, hit subscribe or follow so you get a notification the second a new episode goes live. Talk soon.